All right, hello everybody. Welcome back. We're going to pick up on developing the Astro extension for Harper. Previously, we finished by getting the serving to work of the Astro app. We integrated a static server, static handling, as well as the dynamic handling using the serve static module for the static handling and the Astro handler for the non-static handling. Now, I kind of want to dig into this. We can look a little bit more. So this actually is really cool demonstration of Harper's HTTP middleware. So in this server, which by the way, we need to fix something a little bit. We're going to go in here. We're going to grab this. We always want to pass through these ports so that we can configure that these handlers run on a specific port if we want to. In this example here, so start method, handle directory. The directory, we get the absolute path of our Astro application. We start by retrieving the entry. So actually, this will go down here. We can reorganize this a little bit. So we're looking for the, we start by serving the static part of our app. Maybe let's rename this to static handler, because we have the Astro handler down here, which we'll rename in a moment. So this static handler is created by generating a method using the serve static method on the dist client directory, based on the absolute path of the Astro app. Keep in mind that by returning true at the end of this function, we will not process any more files within this directory. So that Astro app will get processed one time and we're good to go. With that static handler, we are adding an HTTP middleware to Harper that takes the request object, passes it to the static handler, and then as a callback, I believe this is as referred to as the fall through, or they call it the final handler here. I think there's these options up here. There's this fall through, set the middleware to have client errors. Fall through as just unhandled errors, otherwise forward a client error. The difference is that client errors, like a bad request or request to a non-existent file, will cause this middleware to simply next to your next middleware when this value is true. When this value is false, these errors will invoke next error. So typically true is desired such that multiple physical directories can be mapped to the same web address or for routes to fill in non-existent files. What all that gibberish, and it defaults to true. What all of this means is that if, based on the request for a file, it does not exist, it's not in the directory being handled, it will then just call to this callback. Now, it is most likely passing along these instances of request and response to the arguments here. Harper doesn't want those. Harper wants its request object. It's a little bit weird, and we might fix this going forward. We might kind of switch our middleware system to actually match the middleware system that's common with Express and Fastify and all that. But for now, you can kind of think we're just kind of throwing away the arguments, and then we're just going to call our own next middleware with that request object. Cool enough, that's actually going to go directly to this function, which is getting added after this one is. So here, this is our dynamic handling. We are going to retrieve the server entry from here. This file actually has some really useful information, this entry. I was looking for the docs on it, and I wasn't sure where that was. I wonder, let's just do this. Let's just go to one of these files. I have a bunch of these open. Let's just look up entry. Server entry point, maybe? No. I'm like looking for a type for this entry object. I'm sure it's in here, but I just haven't found it yet. Oh, maybe it's this. Astro adapter, no. This is all the building, like entry point, server entry point. That was we just looked at. Dev toolbar. No, we don't want that. Content collections API entries. Don't want that. So I'm not sure. Like I feel like it's probably in here somewhere, but regardless, the value that's returned here did have some useful information. It had actually the client path. It also had the server path. It's worth considering using that going forward. Like for example, if it's possible to define like additional configurations here, we might consider that. But for right now, it's nothing to worry about. The important part is that we dynamically import this entry file. It is MJS. I do wonder, like, if in different Astro versions, like different Astro majors, if this value is different. Again, for the purposes probably of this video, we're not going to concern ourselves with that, but that is a very real thing that we might have to do later on. If, let's say, someone wanted to build an Astro 4 app instead of, I think it's Astro 5 is what they're on these days. Yeah, Astro 5. So all that in mind, like, we just don't know exactly what it'll all do, but regardless, you can async import MJS just fine. We retrieve the handler from that object, and then with that handler, we do the same thing we do above, where now we just get the request and we pass it in here. Now I'm wondering if with this Astro handler, I bet we should do this too. I think we should probably do what we did in the previous one, because I think Astro is pretty slick with its middleware system, where if that doesn't get called, we're going to want it to pass through. So let me close out some of these. I have a ton of these open. Server entry point, that was what we were looking at. But I want to Astro node. Is this where were we on this page? Good. So like in this function, like you're passing, because you see how we do this SSR handler just gets passed to use. Well, we know the function signature of use. They're doing it up here. They're doing the fastify static, and here they're doing express static. Like we understand, these systems work very similarly. So it's a fair guess that if the Astro handler doesn't operate on the request either, that we want to pass it through. We can actually test that. Let's do this. So let's, yeah, okay. I kind of want to see how this works. So right now, let's just run our app again. HarperDB run dot. Okay, let's go over here. Let's reload the page. Everything's working. What if we go to a page that's not defined? Ooh, see, so it just continues to load. It actually doesn't do anything. This is an interesting situation to consider. Should there be an Astro 404 catch-all for this, or should this pass through? So that's kind of what I wanted to do. Is now let's add the Harper status check component. So I believe if we do HarperDB deploy component, and then we do package equals HarperDB status check. I think, Harper must be running. Okay, so let's just run this. Now locally, I'll show a different way to do this. So this is something that you can do locally. You don't need to do this like with you don't need source code to do this. You can just do this if you're installing Harper on your local machine. We have our path to the HarperDB here. So I'm actually going to do a quick or maybe I just do this code, this HarperDB config.yaml. Will that open? Oh, it didn't open up in this editor. It's opening up in the editor. I don't want it to. I wonder if I just close that editor. Now will it? There we go. Great. So, sorry for the workaround. So this is your root config for HarperDB. Wherever you install Harper, like when you do a global install of Harper for the first time, this gets created. And this is actually where, there is a status check component that you can integrate. I have the source code locally, but you could also just specify it here like this, and it will work. What I was trying before with the command line, will also be fine. You have to run Harper first, and then you can deploy this component by name. But for the sake of this, I'm going to just kind of continue using my local reference. But again, it will work just fine if you do the remote one. If I run HarperDB now, we should see status check gets enabled. So if we go back over here, we reload it, you'll see the status endpoint. Status endpoint is reporting for duty. Great. So let's stop that. Now let's run Harper again, like within the Astro extension. And let's go back to our root path. So we get our Astro page. Let's go to SSR. We get our SSR page. Now let's check status. Cool. So now I think this is what we really want, where now if the Astro site is not rendering a certain page or something, it passes that request through to the next handler. In this case, it's the remaining of HarperDB. I do think it's interesting. So right now, these middlewares are being added to the end of the existing ones. So depending on load order, I do think the status endpoint gets hit first, and that's why it's resolving. I wonder if we set this to run first, or I think, is that the, let's see, we have to check it out. Yep, run first is what it's called. So if we do run first true, we also put that up here, and then we retry it. Now what is going to happen? Let's figure it out. Okay, so it's stuck doing its loading again. So this tells me that there's something to do with Astro's configuration here, where if you're specifying a path that's not in your Astro app, what does it do? In this case, it just kind of loads forever. It's interesting. I don't necessarily know why, but it is. We can actually look into this a little bit. Let's just end the server here. We don't want to continue with that. Let's go back to our Astro docs, and like, I'm going to make this a little bit bigger. Is there maybe a like 404 handling? Oh, spinning circle of death. There we go. Okay. Custom 404 page. Let's see what this says. So you can create most deploy services, we'll find and use it. This will build to a 404 HTML page. Do we want to try that? Let's see what this says, like deployment guides. Okay, so this is kind of like that. This doesn't include Node, does it? This is the dedicated sites. Interesting. Routing. Server mode. So in dynamic routes are defined the same way. Okay, this is dynamic routes in server mode. It's not exactly what I wanted. Static routes. Huh. Okay, well let's start with the 404. Let's go from there. So go back to our pages, and let's do a new file, 404.astro. And then we can integrate our layouts. Let's just grab this code. It's going to be a static basic, and we're just going to say 404 not found. Missing out my HTML. Jeez. And then we'll do page, and we'll say navigate back to home and try again. And we can do like, let's make this an A tag, and we'll do home href. Oops. Okay. Let's run this again. So let's review how we're doing it. So these are going to run first. So if we're in that case, if we refresh this, okay, still kind of gets stuck in its, oh, you know what we didn't do? We didn't rebuild, which is the real purpose of this. we do need to do our building, the build part to this extension. But let's refresh this. So even when we rebuilt it, when we're hitting the status endpoint, it does seem like the Astro handler is not handling it, and something is not completing the request. So I wonder, like, can we console.log here and say, like, handler callback called? Let's look for that. So let's run this again. There we go. So I had a feeling this is what was happening, where, you know, you can see handler callback called. So this callback, you know, I guess the static handler does not see what it needs to see. The Astro handler does not see what it needs to see. So then it gets here. And then next continues passing along the request object. I guess the question is, you know, why is this not getting handled by something such as status. We know that this endpoint is configured correctly. We've tested it before. So why isn't it getting passed through? This might be a bug with the HTTP middleware for Harper. More so, maybe the status endpoint generator for that extension might be also trying to run first. So who is actually running first still, or something like that. Regardless, I don't think we're going to solve that issue here today, but it was a good discovery, good to play around with. I am intrigued by the fact that we're not getting that 404.astro. I am wondering if, based on this documentation, it's like you can create and then this will build, most deploy services will find and use it. I wonder if, like, let's turn this off. What if we just ran npm run dev? We go here and we go to a page that's not found. So Astro's dev server handles 404s. If we go into our Astro config, and I'm sure if we do a standalone and we run it again, npm run dev, and we open this up. Oh, well, that's not what I wanted. npm run build. We're in standalone mode. Then we do node entry mem.js. Then we go here. And again, if we go to our, undefined page, we get a 404. So the Astro, Astro dev server and standalone server all handle this, but the middleware one does not. That's interesting. We probably, this might need to be, let's go back to the Astro node docs, if we can find them. Does this have anything in here that would tell us what to do? I'm not seeing anything. So these examples, at least, are missing it. You can also pass it. Okay. So these docs don't mention it, but I wonder, like, let's keep playing around with this. Let's go in here. Let's console.log or logger.debug just Astro entry again. Let's see what it spits out. Harper run. So I will say we're not seeing, there's nothing that indicates in here that there's like a 404 handler. So I wonder if we look inside of dist in client. So 404 HTML does still exist. It does seem to be a static endpoint. This 404 handling may be interesting. There is a server handler for 404.astro as well. Contents removed by Astro as it's used for pre-rendering only. That's good to know. So that one doesn't do anything. I think this 404 handling might be something we're not going to be able to solve at the moment. Like I mentioned before, it seems like there might even be something wrong with Harper's own HTTP handling, as in this next request, like, probably should have delegated to that status check endpoint, but it didn't. I don't know why. Without digging into Harper source, I'm not going to be able to figure it out, and that's okay. I'll make note of that. I think we will kind of move on from this now, and let's get back to building. Yeah. So let me just kind of close these out. This was a good exploration. We really kind of got to experience like what was going on. I don't know if I want run first to be there. It seems to be causing some bugs. I guess if you have like that status check endpoint, you'd want that to hit first. But if what if you had a status page on your Astro app? Which one should hit which? It's some good questions to think about. So let's just move on from that. And instead, let's worry about building. So going back to building, let's look at the next framework for inspiration. So the next app does have this pre-built property for the config, which is pretty useful. That means that if you build your app locally and you deploy it with that dist folder, we don't need to rebuild it on the server, on your deployment. We'll just use what you've already provided for us. I think that's a good feature to re-add. So let's go ahead and specify that one again. but we will default it to false. Again, I'm pretty sure that's the exact same way that we do it up here. Pre-built goes to false. Great. Okay, and then in our start method, so we have all these server handlers. Let's actually do what we do in the next one. Let's create a function, async function, serve. And then let's copy and paste all of this code into serve. Let's get let's call it, or we'll say absolute path. We'll just name them what they are to begin with. And then for options.server, we can just probably pass in server. Let's look at what we do down here. Okay, we have config component path server. Okay, so let's maybe just copy that. Config absolute path server. And then now that we have this, we can rename it to component path, a little bit more useful. For server, we can drop the options. We can just reference the argument. Yeah, and that config is important for the ports. So then in here, we can finally run, we can probably await serve, and then config, absolute path, and then it's not resources, it's options.server. I don't think we're going to use resources, so I'll just get rid of that one. And I also don't think we're going to use URL path, so I'll just make it an underscore to indicate that it's not necessary. Finally, getting into building, we're going to do that check, if config .prebuilt, and next does it in the .next directory. So like we could probably do like if config.prebuilt and it doesn't exist sync, that'll automatically import that for me. And then we want to join the absolute path with probably a dist folder. That seems to be the default, at least. We are going to want to throw an error. So we're going to throw new error, and we'll say pre-built mode is enabled, comma, but the dist folder does not exist. But the Astro application dist folder does not exist. Great, easy enough. So next, we're going to do an if, not config.prebuilt. We're going to await this build function that we're going to write here in a moment. We're going to pass the config, the absolute path, and likely the options.server. I don't necessarily know why that's necessary just yet. Why did we do that in... Why did I do that in... Interesting. I didn't actually use that server in the build method for Next.js, but I am referring to it in the source code, so maybe we just drop that. I don't think we're going to need it. But now we're going to go ahead and create a new function, async function build config component path. Great. So I love this method, this build method on the Next.js side. One thing you need, I've mentioned it before in passing, but HarperDB uses worker threads to execute components. And for a lot of Harper instances, especially ones in production, they're going to have lots of threads. Here I'm indicating my local is only using one. We can configure this to use many. The key to that is you don't want to build the app on every single thread. You likely want one thread to build it and then have all of the threads serve it. So right now, the serve method is already just looking at that component path, that dist client component path. Great. I don't think it needs to do anything else. Because the build, when you execute the build, the Astro build command, that dist directory is going to be created within the source directory, within the app directory. So we'll leave that as it is. But looking at the source code that we have for Next.js, I'll kind of walk us through it. But this is something we created. It's like a file-based locking system. So we'll start with start time equals date.now. And then we're going to create a build lock path. So do join temp directory. And then we're going to do .harperdb astro build.lock. Your classic .lock generally is an indication it's a lock file, but then you always want to give that lock file a pretty descriptive name. So here I'm just combining the path of the temporary directory and then this build lock file. So then within here, we're going to do a while true. We are going to first try, and then, I'm kind of just rewriting some of the code that we have over here. I'm going to walk us through it so that we can explain it as we go. But we're not likely going to make much of a change until we get down here to figure out how to actually indicate if like the build is fresh and like actually execute the build command. I'm using shell quote in this module. Like we'll see if we have to reuse that again. We might skip over the performance metrics, but like we can also work on including that. But just bear with me as we implement the file lock. So let's create the file descriptor for the file lock. So we're importing that. We're going to use the WX, and then, where did that go? Where did my cursor go? Now we're going to write synchronously the build lock file descriptor, and we're going to write the current process identifier to it. If the OpenSync errored, so if error.code equals exist, now we can try something different. We should try and say if the stat sync of the build lock path .mtime ms is less than start time minus 100. We're adding a little bit of tolerance in there, that 100 milliseconds. So we say, I have a comment here, like the lock was created before, any of the threads started building. We're safe to consider it stale and remove it. So then we can use the unlink sync method and build lock path. If any of that part failed, we will check that error.code. If it is enoent, I believe this one means that it was already removed by another thread. So as in, like, if you think about this, you have more than 2 threads. So maybe you have 3 threads. And thread 1 creates the file lock. Or, sorry, if all 3 threads are executing this code at the same time, they're all checking the stat of the build lock path. But one of those threads will be slightly ahead of the others. It's kind of how the nature of Node.js works. It's not truly parallelized. Like this isn't truly happening simultaneously. So if one of the threads determines that this build lock path has an M time that's stale, and it unlinks it, it deletes the file essentially. And then simultaneously, or I guess like within like the next couple milliseconds, microseconds, whatever, another thread does that exact same check. There's a chance that either the stat sync or the unlinked sync will be like, hey, this build lock path doesn't exist. Like it's already gone. So we want to catch that, and we just want to continue. Like we don't want to worry about that case. Otherwise, we do need to throw the error because like maybe there's permission errors or something. Maybe it's a race condition. We're not really sure. We're still within this exist endpoint, or this if block. So let's do a set timeout for 1,000 milliseconds, and then we'll continue. So let me go back up here. I need to add that there. This one doesn't always get done correct. So set timeout from node timers promises. Perfect. So going back through this, we're gonna look. So we're gonna go over here. We'll add that missing throw error. And I'll walk us through this part again. So if you consider there's multiple threads, right? They're all entering this function at the same time. They're all creating a lock path. They're all opening that lock path simultaneously. They're all writing to that lock path simultaneously. One of those threads will do it first and will get it correct. The other threads, when they try to open sync with WX, where a path that already exists, they're going to hit this error code. And again, if it determines that it's not stale, as in like, we just want to continue. We actually are going to wait 1 second and then continue. But that one thread that does get successfully will never enter this catch block and we'll just move on. So that goes into our next section here. So now we're going to try and check the validity of the build. So here, maybe we should do like this. Like we'll add some comments. Lock file handling. And then we'll say like build staleness check. So we'll go ahead and just finish building this catch error. And now we need to ask ourselves, like if we look at this code here, so we know if the build ID, so in Next.js, they output this build ID file. That, at least within the latest majors of Next.js, is good enough for determining the build ID or the validity of a build. Here we have two folders, client and server. I'm not really seeing anything in here that would be like, a build ID equivalent. That said, I do think the fact that we're contingent on entry.mjs as our like exports, like that's the exports file that we use later in the code, that might be good enough to base our check on. So let's just go with that to start. So we're going to just implement this as done on the other side. We're going to join the component path with dist, and then probably want to do server entry.mjs. And then we're going to have that stat sync as my purple brace, give us some more space, and then mtime.ms, and we're going to make sure it's greater than the start time. And if that is, then we're going to unlink the build lock path, and we're going to break out of the while loop. So we're checking if that is fresh, and if it's not, we end it. We end execution. We break out of the while loop. If we are not stale, or if the build ID file does not exist, so like if stat sync, if the file is not there, then we know that the build probably hasn't happened yet. So we're actually able to just say, like, if the error code is not ent, meaning the file doesn't exist, throw that error, because we want to know what's wrong. Again, is there a permission error? Did something else go wrong? Who knows? So moving on, now we want to build the application. So in the past, I've used this shellquote.parse, and I've added the ability for like a custom build command, because in my experience with Next.js apps, sometimes you want to do that. I think for the purposes of this video, we're going to skip over that feature. Likely, when this extension is released into the wild, all of those little features will probably be included. But just for now, to kind of get things running without adding in a whole nother dependency and whatnot, I just want to try and using like a default build command that we know will work for our basic Astro app. So we're going to go down here and we're going to do exactly like this Next.js extension does. I'm going to do const standard out, standard error, status, and error. And we're going to do spawn sync from the child process module. And we are most likely going to do Astro and then build. And then we are going to want to pass in the current working directory is going to be the component path. And we'll always specify the encoding so we get useful human readable outputs. So with that, I do need to check something. So in this app, what did I set the default build command to? I think I use npx for that. Yes. Okay. The reason why I want to do that is that this command may not actually be able to see the Astro dependency related in node modules. What all that means is that when you are in package.json and you have a build script like Astro build, Astro is not in my path. Like if I do which Astro, it says Astro not found. So if I just run the command Astro, it doesn't work. It doesn't work, and it's not loaded into my path. But magically, if I run npm run build, it is. How does that work? It's because npm actually looks into the node modules folder .bin directory, and it loads any of these are executables that are being loaded by the dependencies of this module. Here, Astro is what's actually being executed when you call Astro build over here. There's this nifty tool called npx, which if you then specify Astro, it'll look for the relative node modules folder, the .bin directory, find a matching executable, and then run it. If that executable doesn't exist, npx will go up into the npm service registry and try to find it. So like if you did the classic, well, like here we don't have HarperDB in here. So if we do, actually that'll probably work on my machine because I have it globally. What's another npm executable command? I mean, I guess Vercel. We don't have Vercel in here. If we do npx Vercel, it's not installed. So you'll see need to install the following packages, Vercel at. We're not going to go forward with that. But that was just kind of as an example of like when you run npx, it will try to use the version relative to your project. But if it's not found, it'll go and fetch it. We're not really going to worry about that whole experience. Harper does install the dependencies of your module for you using npm. So assuming that the Harper dependency installation step works as expected, Astro will be included. And by executing the command as npx astro build, we'll be good to go. That was a long tangent into that detail, but nonetheless important. So finally, let's check the status code of the command. And then if standard out, what's that mean? Why? Oh, if the standard out variable exists, then let's log that to the screen, or let's include that as info. There is this performance analytics thing. Again, we're going to skip over that for the purposes of this extension build. The source code is here. It'll likely get added one way or another to this module at some point, but for right now, we won't have to deal with it. And then I'm just going to copy what this extension does, and if these exist, we're going to log them. I don't actually want to break or throw an error if this command fails, because Harper as a system, you don't want to shut down the process. You don't want to throw an error so aggressively that like Harper just shuts down because you couldn't build your app. You want the rest of Harper to keep running. You might have to do a redeployment to fix your app, but you don't want it to just completely shut down. After all of this, after the build works, we are safe to finally unlink that build path and break out of this while loop. By the way, I believe this build staleness check, I think this is what is also determining like, hey, like if the build is good, we can just break out here. That's what this is checking. Meaning like, if you think about it, if the last modification time of the entry is greater than the start time of this process, that means likely that another thread has successfully built the Astro application, and this thread doesn't need to worry about building it. So you can release the build lock if it exists, and you can just break out. Yeah, and we can test all of this by adding some worker threads and seeing how it works. Okay. So with all of that complete, let's try running this on Harper and seeing how it all works. So we're going to make this a little bit bigger because we're going to want to see our terminal output here. In our example, let's delete the dist folder. It's gone. If you tried to run Astro right now, it would not work. There's no build. But if we run Harper run on our app and things are built correctly, we should see, hey, there we go. Okay, we're getting, so here's that info line, and here is the output of the Astro build command. Very cool. It's not the not the cleanest because it kind of like is it's like it has its own log format that's getting mixed in with Harper's log format. Again, not the biggest detail, probably can be improved, but it looks like we built successfully and we didn't get any other errors with running the app. So let's go back over here and let's go to that home page, and there we go. It seems to be working. If we go to page 2, it's there. If we go to SSR, that's still working. We refresh, it's rendering on every page. I think that's golden. That now we have building working in our Astro app. Now let's see something. Let's go ahead and do okay, let's try this. So if we actually hold on. Pause. probably worth cutting back at that moment when I said building works. I need to figure out where I want to go with this. Give me a moment. I know where I want to do. Okay. Restarting in 3, 2, 1. Okay, so we just finished successfully building the Astro app. We have all this lock file handling in here, but we actually haven't tested that part out. It also looks like config is not being used. That's fine. That was because in Next.js, the config is being read for that build command. We might add that in now. That might be a good way to, it might be a good one to do while we're at it. But let's try and test out the worker thread simultaneous building. So let's go over here to our HarperDB config.yaml. Remember, if in the previous episode video part of this thing, you might or might not have caught this, but we opened up our HarperDB config.yaml. Everyone has access to this file. If you install Harper locally, even when you npm install it, you will get this file generated on your machine that you're able to then modify for your Harper instance. Here in this count, for threads, I'm going to increase this to 4. So let's make 4 threads for our Harper server. And I want to actually delete that dist folder again. If we built our file lock system correctly, we should see only 1 build output. So let's just see what happens. Okay, we know we have 4 worker threads here. And we can see, looking at our logs, we have HTTP 1, 2, 4, I'm assuming 3 is up here. It looks like everyone's booted up. And you can see here, HTTP 2. So it looks like thread number 2 was the lucky winner. It was responsible for building the directory. We have the Astro node adapter. And if we go over to our browser and we refresh this, it seems to work. Go to forward home, we get our page. So this is awesome. It means that our build process is now working across threads. Wonderful. So that kind of concludes at least the build portion of this feature. And we included this testing of using the threads for the extension. While we're in here, let's go ahead and add that config. I think it's pretty useful to have. So go over up to here. We'll do build command, and we will do an options build command, or we will set it to npx astro build. And let's go back to the next app. I think we use this great dependency called shell quote. Is it just that spelled like that? Oh, it's shell hyphen quote. So let's go into our extension npm I shell hyphen quote. I don't mind adding dependencies like this into a module. I find they're very useful. Like getting shell parsing correct is not something I want to have to maintain from project to project. So a dependency like this is quite useful. I think it's actually built by a friend of mine. Shout out. Okay, where was that going to go? Great. So down here in the build, before we execute the build method, let's get that path from the option. So now const command ... args equals shellquote.parse config.build command. So again, this is why I really like doing the config resolution, is like now whether you specify build command or not in the defaults assigned, we parse either one using the same method. So then down here, I can simplify how I call this, and I can just go here, and then I can pass the args list the second, and it's good to go. We can try and test this out ourselves. So let's go to config.yaml. Let's go ahead and add a new build command. Let's say echo foobar, and then and astro build. And if we go back into the example app, actually we could probably just be doing this, run example. Oh, I think I saw it. Ooh, interesting. Something might have broken this time. Foobar, object to object, Astro build. Interesting. What is this doing? I wonder if this is because... Oh. This is very interesting. Because of the way we're shell quoting this, this actually wasn't a very valid test, because I think it's now, it's literally executing npx and then echo foobar, all of that, right? How would we confirm that? Let's put this down here. Or would it be actually running npx? I think the command gets pulled off as echo, and then the rest of the arguments is foobar and astro build. I'm sure we can see that. We'll say command. Oh, we should use logger.debug. Some of those console commands will work depending on how you've configured your Harper instance. But I don't want to deal with it, so we're just going to use the debug. It works a lot better. Let's run the example again. So here we go. We're getting some good output. So the command is echo, and then the arguments, is foobar. Somehow it's so shell quote is parsing the and as that. It's very interesting. I didn't know that's how that would work. I thought that shell quote would handle the double executor. Interesting, nonetheless. We might not have to worry about dealing with this right now. It also seems like I might be using shell quote wrong. I might want to do the default import. I didn't realize that. All right, well, maybe that's worth changing. Can we do that? Parse. Oh, I know what I did, because I'm just calling shell quote.parse. It's fine. Okay. Interesting. Oh, so it has operators. So if I do or, you get output, beep, up, beep. Interesting. Oh, that's exactly what it's doing. Here we go. So this is cool. So this is demonstrating right away that even the Next.js extension has a bit of a bug in it. We're not actually properly handling an input here, because I guess I was assuming that you could just kind of execute everything all at once, but in reality, what you need to do is kind of process this output as a shell might, right? Where instead of just taking all of the arguments here, we'd actually want to iterate over this list. If an operation comes in and it's like or the caret, or it's the pipe operator, or it's the or it's and we might, we would probably have to put this part into a loop. Let's build this. So let's go ahead and just do. Oh, interesting. I wonder how this would work. Well, we saw that here, right? Where we have arguments, foobar, and then comma, object, and then you get Astro build and the rest of it. So, this is going to be interesting. Naively, what I want to do is something along the lines of, Interesting. Let's just say, let's call this output for now. And let's do like for let I equal 0, I less than output.length. I just want to go raw iteration for a moment. And we basically want to say might want to use a function here, but I can wrap this in a, let's just get real hacky for a moment. Let's kind of work our way through it. So let's say const, or maybe we'll do this, done. Let done equal false. So while not done, do this forever, over and over again. We're going to want to do like a let current command. And then we can do like, or like, what about this? Command arguments. Is that reserved? That's reserved. Can I just do args? Args isn't reserved. Okay. Then we're going to want to do an iterator. Let I equal 0. And we're going to say like output I. So like if output.I. I wonder if like how would this parser? So let's go down to here. Let's go to node const parse equals require shell quote. This is also like, I'm sure there's something that already does this for us, but I feel like building it right now, and you guys get to watch that happen. So if we did like this and echo foo, how does this parser work? So it does consider the first op. It's interesting. Maybe do that. We say like if type of output I is string. Okay, so we're going to say command equals output I, and then we're going to want to do a like while another while loop maybe. Oh, I don't know. This is getting kind of out of hand. I guess I'm kind of like going down a path of we could probably spend a few hours building this resolver, when in reality I am like 100% certain there is something that already does this for us. I am, it's Jordan has built this shell quote utility. I am sure there is a similar module that will execute this. I wonder if we want to use like, is it like npm exec module? No, this is not it. There's some other ones that are better for this purpose. I guess I thought this was suitable, but it's not. What would that one be called? It's one of Syndrasaurus's tools. Let's go to his page. It's one of his projects. Execa. I think this is the one we want to use. Process execution for humans. So I think, let's just check this out. So basic execution. So you are able to break it up. You can use the template string. Very interesting. So maybe let's replace this. Let's add that. Let's npm install execa. Cool. Hey, I'm doing something new. All right, let's throw that in there. Will this work with like an and? Like, can you do two? Let's go back to the docs. See if it has. Okay, so it does have this like this scripting. So that's like if you wanted to build a script, but like what if I wanted to execute someone else's string? It's still using the sort here, or sorry, the pipe calls. I guess let's just try it. Let's do this again. Node. Can I import execa from execa in here? Can't use it. Okay. Then let's do a dynamic import. Okay. So execa echo foo and echo bar. What did that result in? Oh, it was a promise. Okay. Await. Here we go. Oh, interesting. So this also, so that's too naive because it's still doing the whole thing. We want to see foo and bar. So does it allow for parsing of the input? Huh. I mean, like, what if I just search for the and? Nope. Piping, streams, debugging. Differences with Bash and ZX. No globals, no binary, no shell is used, only JavaScript, no shell injection, all exec, okay, easy to debug, verbose mode, performant. Do I need verbose mode? Okay. Yeah, this is interesting. I guess the other thing we could use, right? I think that before we were doing I was calling in this file, we're down here, we're calling spawn sync. I guess we could just use exec sync, couldn't we? How's that going to work? Let's look up our node docs on exec sync. Would that do what we want it to do? The full command. Does this return? This returns the standard out for the command. I see. So we wouldn't be able to see the standard error. I think it would, what, throw the error if it happens? Will not return until it's fully closed. If process times out, this method will throw. Okay. So I will say, like, what if we just try, let's switch this all up. Man, maybe, I mean, this would be a whole nother video, is building a command parsing algorithm. I think, yeah, why don't we try this? Try exec sync config.build command, and then we'll take these arguments in. Get rid of all this code. And let's catch the error if it's thrown. Or we'll say we'll get standard out from here. Say if standard out, logger that info, standard out. And then if error, let's just, probably worth doing a logger.error here, like just flat out. But we don't need to exit anything. So let's give all that a try. Cool. All right. We're going deep. Let's run this again. Let's see what happens. Ooh, okay. Exec sync is not defined. All right, good to know. I need to add that over here. Great. We can get rid of that import. Try again. Still failing. Astro, command not found. That's fine. We know that. We need to do npx. But I think that proved it. I think we're working now. We're going to get a foobar standard output, and we're going to build. Huzzah. All right, cool. Yeah, we're printing out foobar. That's the echo foobar, and then the and is getting handled by npx Astro. So we just overcomplicated things by adding all the shell quotes and execa and all that, when node exec sync seems to handle that just fine. I think it's because it truly just executes that string as is. One thing to note is that, again, if you tried to do this without Astro, I think this is where we might want to do, we can consider for the path, could we set the path to include node modules? Max buffer including Windows hide. No, I don't think so. I know you could do that with spawn sync, I think. You can with spawn you're able to provide a path override, aren't you? Maybe not. Oh, I'm sure it's this, wouldn't it be? We could probably do something like env and then path is process.env.path. And then you can do like this is getting fancy. We do join component path no modules bin. Now I bet this will work. Let's try it. We might not want to do this. Something's not working. Environment node. No such file or directory. Okay. I might have rushed this. This might not be actually the right way to do it. So let's just ignore that. I don't think we need to override the environment or the bin or the execution path. I think we just let this be as it is, and you need to specify npx Astro because that's what we do default anyways. You don't get to include, we don't include your node modules by default. We can get there, but I think this is pretty satisfactory for our purposes. Again, we'll run it. We've got all 4 threads running. Who won this time? It looks like thread 3 won, and we can specify that custom build command. Awesome. That took a lot longer of a rabbit hole than I expected it to, but here we are. Don't try to build a custom command parser. I'm sure we only spent a few minutes on that, but probably not the best use of time. I think doing this is just fine. And this actually demonstrates, hey, like there's something wrong with the next extension. We don't do that here. So this next extension, as I'm recording this, like needs a fix. Likely by the time you watch this video, the fix will be out or it'll be well on my to-do list to get done. But this is something interesting to consider. And there might be some shortfalls of using exec that I'm not aware of. It's the best part about doing all this work this way is there's a lot of different solutions and we'll kind of just figure them out as we go. So I'll kind of wrap the build part here. We really went down some rabbit holes, which was a lot of fun. The one thing I really want to understand is dev mode. And I don't know if Astro is going to let us do that. Now, Next.js does allow for dev mode, which is pretty cool. You're able to you just specify dev here, and Next passes it through, and you're able to use it. I don't know if this tool allows us to specify that. It really just has mode is the only one that I'm seeing. I wonder, can we look at the source code for this? Source index.ts, create integration. Let's see, we got these images, session. It looks like Vite's being used. Okay, cool. SSR, no external. Oh, I wonder if this is because everything uses SSR under the hood. I'm sure their dev server is. I wonder if that's something we can even hook into. Yeah, let's just look through this for a little bit and kind of figure out what's going on. Get adapter, Astro, server, JS. Let's just go look there. Let's see what it does. There was preview. How does preview work? So this is a preview server. I guess the reality is like when you're doing your development with Astro, you're going to just run it locally. There's no point doing it otherwise. The next extension, excuse me. The next extension does this because there's a really cool, the coolest part about our Next.js extension and then we'll demonstrate this in the example, is that, let's see, where is that code? Oh, is it not in here? Oh yes, so it's in the next extension itself. So Harper itself has a variety of globals, as we've seen, including the tables API and things like that. It's super capable, and it's actually leverages really fast development when you're able to call into the Harper database part directly from your JS. The only way you're able to do so is if you execute the JS part of everything within the context of Harper. So Harper, has to be the one who's running this JavaScript files and such. It is, that's what we're doing with this Astro handler. Because the Astro handler is being executed within a Harper component, it will have access to these globals, But if you only, but if you run your app locally and you're trying to use these globals, and you're running your app locally using just the embedded Astro commands like Astro dev that run its own thing, it's not running Harper anymore. It won't have access to those global JavaScript APIs from Harper. This is why we added dev mode support to Next.js, because you're able to then hook into that and build your app completely with Next, with Harper, and test it locally using dev mode and deploy it and run it all the same way. Assuming because you can't hack that here with Node, I wonder if there are other integrations available to us, or if there's other reference points, like is there like a developer dev toolbar app API that add apps to the Astro dev toolbar? That's pretty cool. Programmatic Astro API, config file, mode, okay. Oh, here we go. So how does this? So if you need more control when running Astro, the Astro package exports APIs to programmatically run the CLI commands. Very interesting. So there's something to this, but I still don't know. Okay, oh, Astro dev server, await dev. It runs Astro's development server. Huh. How does this... Here we go. Oh, here we go. Okay, dev server. So you call await dev, inline config. It yields a promise with the dev server. A handle for raw node HTTP request. You can call handle with an incoming instead of sending a request through the network. Watcher. This is the FS watcher. You have stop and start. Very interesting. I wonder if the pieces we did before... So this actually goes back to how we built the next extension. I keep referencing that. It's a good example. So if we look at the next extension, you'll see that we do that dynamic import of the next module. And then that's where we're calling, get request handler, and then the app.get upgrade handler. I have a feeling if we really wanted to support Astro like dev mode and even build mode, this is pretty slick. I think we might, maybe as a secondary idea, you could integrate these APIs directly. I guess what we would want to change is inside of this extension, inside of the start method, as soon as you get your path, you would probably want to dynamically import Astro from the path. And then you could programmatically execute all of Astro's embedded things, such as build, dev, preview, and it seems like maybe even... Well, I guess then, okay, here we go. When you get past those defaults, like those simpler methods, dev, build, and here is start. Oh, start, if we're actually running the app, you're going to want to do what we've already done. You're going to want to serve it the way we've served it. But this whole build process, I think instead of calling Astro build, like the command, wherever that lives, instead of actually executing the CLI command here, I think we dynamically import Astro and we call build itself. Interesting. And if it's dev mode, we call dev mode. Very cool. So this is experimental, so that I kind of don't, I don't want to bake everything onto that. And this dev mode is interesting to me because it doesn't really give me like can I provide this dev mode my own WebSocket server? I'm sure not. I must not be configurable. And would that be an issue if my server was running its own WebSocket server? Again, that's why we did it on Next.js. We have this whole upgrade sequence because we wanted to make sure that when Next wanted to upgrade and connect to itself, we do so. It would run on a separate port. Interesting. That would definitely take a longer time for me to understand how to kind of integrate. I think the fact that this is experimental, I wonder how long this has been in. Any updates we mentioned will always show current update information, but it could change at any time. So this one I'm feeling a little bit less secure about building with. I'm also wondering if maybe there are, like, let's get into this adapter API. Config done. Do they have... Here's server entry point, handler, event. Like, let's just read through these. So we have start, render. Like, I wonder if you could, maybe the idea is we have to build an integration ourselves. It's very interesting. Maybe it's the integration API. Here we go. Astro config setup, Astro route setup, routes resolved, config done, server setup, server start, server done, build start, build setup, build SSR, build generated, build done, any custom hooks from integrations. So I wonder how dev mode gets here. I mean, here's toolbar, so that must be the server. Vite dev server, there we go. So it's got to be because it's really baked in with Vite. It's an interesting problem. There's a couple different options I'm seeing here as solutions, but what I want to build necessarily, I'm not entirely sure. I am intrigued. I want to say, like, let's just give this a shot. Well, let's get container API real quick first. Render components in isolation. I don't think we want that. Okay, this is like to render it. Okay, let's go back to here. Let's do this. Let's try to change our build command to use this programmatic API. And we'll go from there. So I guess, I mean, going back, like thinking about it, I'm seeing this, like the values passed to Vite. I just have a feeling that if Astro is not exposing its underlying Vite server, then it's going to be really hard for us to integrate with it. If they do expose it in any way, or maybe they do eventually, that could be how we integrate and kind of like pass through the dev server. But for now, I kind of just want to hack on this a little more. So let's like use this build method. I kind of love this. So let's do what the next app did. And inside of start, by the way, I'm going to remove this custom build command. I don't care about that as much right now. Oh, but I guess if we do get rid of that, then you're stuck doing, your build is going to be programmatic, where the Astro part will only be able to call this. I guess we don't want to do that then, do we? Because if you had a complex app where you wanted to do something ahead of time, excuse me, you wouldn't be able to. I guess this is a moot point. It's an interesting API. I'll leave it there. I thought this would be something, but I guess it's not exactly what we want. It has some other trade-offs that are not entirely as useful. Okay, so this video, or this at least recording, kind of concludes with the addition of the build command and adding, the thread safe build operation. We messed around a bit with how to actually get the build command through. We noticed that the shell quote module actually doesn't do what we thought it did. regarding the, and the pipe operator. So if you had a more complex build command, like if you had something like this, remember if you had echo foo and then mpx astro build, this before was not getting executed as you thought it would. Now it does, because we're just passing it to exec sync. Depending on if it makes it into the video, we also spent some time today kind of reviewing some other APIs, including this programmatic Astro API. We spent a lot of time thinking about it, reading some docs. It seems like it seems like an interesting API that could be used for improving this extension overall, but the reality is it kind of limits other things. In particular, this build site, this build command will not let you actually like do something like this, where if you had echo foo and mpx astro build, we wouldn't actually be able to execute that first part of this command. We could probably do some kind of parsing again and see, as long as this command has astro build in it, we replace that by calling the programmatic API. But then, that gets complicated. If we abandon the idea of a custom build command and just said, hey, we're just going to run Astro build on your app, you can't do anything else. Now we get into a tricky situation where maybe you're going to have to implement, like at our Harper level, we might need to include additional ways to execute things ahead of time. If you need to run a data processing thing, or you need to load environment variables or something, or I guess not load environment variables, but if you need to process environment variables for your build, you can't really do that in a script-like way. You would have to do it in some other layer. It doesn't make a ton of sense. So while this API is awesome and interesting, and it might be the only option for doing a dev server, which we kind of figured out that it might not be entirely possible to hook into because of the lack of like WebSocket upgrade handler support, we're going to kind of wrap up the extension where we are today. We can build, we can serve. It does the static, it does dynamic, server-side rendering, static site generation. I'm very happy with this. I think with this extension, we're going to be able to say like Astro runs on Harper now, which is really exciting. I hope this series gave you an idea of what it's like to build a Harper extension from scratch, and kind of all the rabbit holes you might go down. Don't forget about the HarperDB component reference documentation. We have a ton of details there. That is kept up to date now, so if there's ever changes to the component APIs, they'll all be included. And it really will let you, build the extensions of your dreams. And if you have any questions, feel free to let us know, reach out. With that, thank you for watching, and we'll catch you on the next one. All right, goodbye now.